Hello everyone, welcome back to another in our series of instructional videos on the USM 100 portable flaw detector. I'm Dan here for Waygate Technologies, and today I'd like to talk about using DAC, distance amplitude correction, and its corollary time corrected gain. We've put a few features into the USM 100 that make this particularly easy and fast to set up. So let's get started. I've already gone through previously and calibrated my probe. I have a 1/4 inch MSW QC here with a 45-degree wedge. I've gone ahead and calibrated on my DSC block for delay, probe delay, and velocity for steel. And I've checked the wedge refracted angle and confirmed that it is in fact 45 degrees. So I have a block here, nice rectangular block with a number of side drilled holes. These are 1/16 inch side drilled holes, and they are in the block every 1/4 inch. So 1/4, 1/2 inch, 3/4 inch depth, 1 inch, 1 1/4, and 1 1/2. Nice series of side drilled holes in which to set up. So the first thing is we're on our evaluation panel since we've already done delay, velocity, and angle. If I swipe out the sidebar, the first thing I can do is choose my evaluation mode. And by default it's DBRF. I'm going to come and select DAC instead. And that will change the menu, so now I have things that are appropriate for a DAC calibration. I have a choice of either calibrating using my live A scan or using the envelope feature. I'm going to choose envelope because that makes it much easier to get peaked up on each one of my side drilled holes. The next choice I have is whether I want to use a pre-programmed table. Using create or using the menus here, I can set up a table of points and some number of points that I wish to use, and I can enter the distance for each one of those points, and that'll move the gate to hit the distances that I've told it I expect to have my points at. What we're going to do here instead is use the custom mode where we can set up on our holes without having to know those distances in advance. So I'll leave that at custom, and the rest of this I'm just going to let go for the moment. Okay, I can go ahead and close the menu. Now, since I'm using the envelope mode, let's go to our A-scan menu and we'll turn envelope on. I see it's already on. Okay. So now as I put the probe on my holes, let's peek up on this first one at 1/4 inch. You can see as I scrub across the hole, the yellow trace is my live A scan and the red trace is the peak that it has seen so far. So I can scrub around on there, get all peaked up. I can bring my gate over. I can do auto 80. Okay. And then I can run right across my series of holes. And as I peek up on each one of these holes, you see the envelope just keeps showing me the peak amplitude I get at each spot. Okay, so it helps me get accurately peaked up on each one of these. Where in some of our previous instruments we would have had to have found each one of these holes, peaked up, reached back to the instrument, hit the calibrate button. But here I'm able to simply focus on moving my probe and getting each one of my peaks recorded. Okay. So now that I've had gotten all those peaks recorded, let me move my gate out here, make it just a little bit narrower. Now what I'm going to do is move to my first hole and hit my calibrate. And you see I've begun drawing the DAC curve on the screen, and now I can just go from point to point, calibrate, 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 calibrate. So just that quickly and easily I've developed a curve that fits all of these holes. I was able to peek up on each individual hole very nicely using the envelope feature. And now that we've gotten all that set up, we can go ahead and turn off our envelope. And just go ahead and clear it for the moment. Come back to the A-scan menu, and we'll turn envelope off now that we're done with that. Okay. And now we're back to live A-scan. And I can compare any of these holes to the curve that we just recorded. So we recorded a reference amplitude for each hole. We can see our points, the individual recorded points on our DAC curve. Up top here, in addition to the regular A% and SA measurements and a depth measurement under the gate. Let's get the gate over here and we'll compare that. Okay. In addition to our other readouts, I now have an A% selected here, A% RA. So what is my amplitude with respect to the DAC curve that I recorded? And then we also have dBRA. What is the echo amplitude with respect to the curve? And we can look at these other points as well. So I see that I'm just a fraction of a dB below the curve, and I'm at 80% amplitude with respect to the curve. Okay? Now, a couple of other things to be aware of with TCG. We have, if we look at our gain control up here, we can see that we have the system gain where it was recorded, and we are currently at plus or minus 0 dB from where we recorded. If I wanted to, say, peek up on this hole, and I wanted to see the gain of that at 80%, you notice when I did that, it now has my reference gain recorded still, but it's telling me that I've got 10 dB more gain dialed in than I had when I recorded. Okay. And you see the gain, the DAC curve has shifted almost completely off screen. We can still see a little bit of it out here at the end. Okay. Let's go in here to one of our other holes. Peek up on that. We'll do auto 80 again. Get things back on screen. There we go. I can manually dial the gain back down to where we started. You can see the curve walks right back onto the screen. Okay. If I look at my gain menu, let's take a look at that quick. We have a couple of controls on here that are useful. One is transfer correction. So we're setting up on a nice clean calibration block here. In the real world, I may have surface roughness and things like that to deal with on my sample, and I can apply transfer correction gain. I won't go into how that's all calculated. Generally it's done with a through shot with a matching probe to the one that you're using, and you can establish how much attenuation happens in getting the signal into and out of your block, or if you have if the material that you're inspecting is more attenuative than your calibration block, different heat treat. Those are all reasons that you might want to apply transfer correction, and that's done here in the gain menu. So we're back to nearly the same gain that we had before. Let's come in here and we will come down a little bit. We'll get back to our calibration gain. So now we're back to our 34.3 with no offset, no gain offset. Okay, so now we see our same curve. Now, if we come in here and go to the evaluation menu, we scroll down here a little bit, we can get some offset curves. So let's take our offset and we'll tell it we want fixed offset, and we want an offset of, say, 3 dB between our parallel curves. And now it's a little difficult to see with against the green gate. But if I move the gate out of the way, you can see we have 4 curves that are parallel to our reference curve. The reference curve is there in red. And in violet, we have 4 parallel curves. And those curves are separated by 3 dB from our reference echo. So you can tell at a glance as I move the probe, as I approach the peak, come off the peak, you can tell at a glance at the A scan, there's 6 dB down from our reference curve. There we go, so about 6 dB. Our dBRA is down about 6. There's a bit down about 3. There's back to our reference echo. Okay? So that's the offset curve feature. That's the essentials of setting up a DAC curve. If we go to our evaluation menu and we look here, we are, scroll up a little bit. I have the choice of either displaying things as a DAC curve, where you have a curve, an amplitude curve recorded and displayed on the screen, or we can switch from DAC to TCG mode. So from distance amplitude correction, we're going to switch to time corrected gain mode. And what this does is calculate the amount of gain required rather to match that amplitude curve. Now instead, we're going to make the curve flat at our reference amplitude, and we're going to vary gain as we go through time on the shot. So that has the effect of each one of these holes should now give us an equal amplitude, and it should come up to the reference line. So as I scrub across here and I see each one of my holes, if I'm doing my part with scrubbing the probe properly, I can get back to 80%. That was the distance amplitude correction and time corrected gain calibration and evaluation. Next time we're going to take a look at AWS D1.1 calibration and evaluation. As always, if you have any questions, please reach out to remote service at bakerhughes.com and we'll be happy to help you out. Thank you.